Good morning and thank you for joining. Welcome to the webinar High Availability and Disaster Recovery hosted by Cloud.in. I'm Swarna Jadhav working with Cloud.in as a strategic partnership and alliance manager. For today's session, we have Ms. Rutuja as a speaker. Rutuja is working with Cloud.in as a cloud consultant. She will guide us on the designing a high availability architecture, data backup and recovery strategies, cloud-based high availability and disaster recovery. Additionally, she will walk us through a few case studies. Before starting the session, I would like to mention a few points. All attendees are muted by default and cannot be unmuted during the session. We will have a question and answer session at the end of the presentation. If in case you have any questions in between the session, please raise your hand to grab the speaker's attention or ask a question through the questions section. I request Rutuja to start the session. Over to you, Rutuja.
Thank you, Suvarna ma'am. Good morning, everyone. Rutuja here, and I will be giving you a brief about how you can build a high availability and disaster recovery infrastructure for yourself. So let us look at the agenda for today's webinar. Firstly, we will look at the introduction to a high availability and disaster recovery. I mean, what does high availability and disaster recovery in cloud's perspective mean? Next, we have a design architecture of a high availability and disaster recovery. Later, we will be looking at how can we have a data backup and recovery strategies implemented. Moving on, we have cloud-based high availability and disaster recovery methods that we can implement. And lastly, we will look into a case study wherein we have implemented a disaster recovery, how it has helped the company to meet its business needs and all the problems that they were facing before. So let's move on. Now let us first understand what high availability exactly means. So here, as you can see, high availability actually focuses on minimizing the downtime and maximizing the uptime, wherein we by implementing redundancy, load balancing, and failure mechanisms. So basically, in your infrastructure, you can make your infrastructure highly available by implementing redundancy infrastructures or by using load balancers for your servers, and also using failover mechanisms wherein you don't have any point of failure to face a problem with if you have a highly available infrastructure. So HA is typically achieved by deploying redundant resources across your multiple servers or data centers and employing automatic failover mechanisms to ensure seamless continuity in the event of a failure. Next, we have disaster recovery. So disaster recovery, in other hand, deals with the recovery and restoration of systems and data after a catastrophic event or a major failure. Catastrophic event can be related to maybe a flood or a hurricane or something like that. So this basically aims to mitigate the impacts of such events and minimize the downtime or data loss that you might face if a disaster occurs. So there are 4 disaster recovery strategies that AWS offers us. This involves data replication, backup, and restore procedures, failover, failback processes, and regular testing to ensure readiness. So DR typically focuses on the restoring services and data to a known good state after a disaster, whether it's due to hardware failure or a natural disaster, as I suggested before. So mainly the impact that a business has by implementing these 2 methods is that high availability and disaster recovery in the cloud complement each other. So high availability basically measures basically helps you maintain continuous service availability and reduce the downtime, where disaster strategies ensure that systems and data can be recovered and restored after a disaster or a major failure. Together, they actually contribute to the resilience and business continuity of your cloud system. So you must consider the availability of your workload in a disaster recovery planning, as it will influence the approach that you take. A workload that runs on a single Amazon EC2, for example, in one availability zone does not have high availability. So if a local flooding issue affects that availability zone, this scenario requires a failover to another availability zone to meet the DR objectives. So compare this scenario to a highly available workload deployed over multiple availability zone, that is multi-site or active-active DR strategy that AWS provides. So where the workload is deployed, wherein the workload is deployed across multiple active regions and all the regions are serving production traffic. So in this case, even in the unlikely event like the massive disaster makes a region unavailable, the DR strategy is accomplished by routing all the traffic to the remaining regions. So if you have, for example, a server in availability zone 1 and you have the same DR strategy applied to the availability zone 2. So if the first availability zone fails because of some disaster, climatic disaster or something, you have the other availability zone wherein the traffic will be automatically routed and you won't face any failover. So next we have the architecture. So as you can see, as I said, Route 53 will directly is connected to the elastic load balancer in one region, and another region also it's connected over there. So in the first region, as you can see, there are two availability zones having the basically this architecture shows you a highly available as well as a disaster recovery architecture, wherein the availability zone has the same instances. So as I said, if first availability zone doesn't work in some scenario, it fails down, you have the other one. Same goes if by some major issue, if the region also doesn't support, you have another region also. Moving on, we will see how we can implement redundancy and failover mechanisms. We'll deep dive into the methods that we can implement to have a redundant architecture. So implementing redundancy and failover mechanisms is a very crucial activity. This for achieving high availability and minimizing single points of failure in cloud environment. Here we will see some strategies or techniques by which you might implement redundant and failover architecture. So to have the first point that we have is redundant architecture. To deploy redundant instances, we can run multiple instances of critical applications or services across different servers or virtual machines to ensure availability. These instances can be distributed across multiple availability zones, as I told you all before, or maybe data centers also. So we can also use load balancer. So using load balancing, this will implement you to distribute the incoming traffic across multiple instances, ensuring efficient resource utilization and also preventing the overload of the individual instance if it is facing any. Next, we can also have the database replicated. So you can set up your database replication such as master slave method or multi-master replication method to maintain multiple synchronized copies of the database. So this ensures that data remains accessible even if one database instance fails. So you have the other database active. Next point, we have the automatic failover. So we can implement health checks in this method, wherein continuously we can monitor the health and availability of the application that is hosted on the instances. So health checks can detect failures or degraded performance of your servers or the services that you are using in your infra. So we can also use elastic scaling to leverage auto scaling capabilities that is provided by the cloud providers to automatically scale the resources up or down based on your demand. This helps handle increased loads and can trigger failover mechanisms if the instance becomes unresponsive. So you can on your demand, we can as per the need. Also, we can configure automated failover setup. You can set up policies or scripts to automatically like redirect the traffic or switch to a backup instance when a failover or degradation is detected while monitoring. And this can be done using features like, for example, if we consider AWS Cloud, there is a feature called Amazon Route 53 DNS failover. Or if we consider Azure Cloud, there is a service called Azure Traffic Manager. So wherein you can set up policies or scripts to automatically redirect the traffic. Next point that we have is the data replication and backup. So herein we can replicate the data across multiple locations. So you can use cloud provider services like geo-redundant storage or multi-region replication to store the copies of data in like different geographical regions. So this protects you against the regional outages or disasters. And we can also take regular backups. So you should definitely perform regular and configurations in your infra to store the backups in separate locations or use cloud-based backup services to ensure that data can be restored if the primary data is lost or corrupt. So if you use the cloud-based backup services, you have an immediate access to it. So you can immediately access to the backed up data in the service if your primary data is anyhow lost. Next, and the last point that we have is testing and monitoring. So regular testing is very important. You should test the redundancy and failover mechanisms periodically to ensure they work as expected, and conduct simulated failover scenarios to verify that the system's ability to handle failovers and recover is pretty much good. And also monitoring and alerts. You can implement robust monitoring systems to track the system health and performance metrics and potential failovers of your services that are in use. You can also set up alerts and notifications to promptly respond to the issues and take necessary actions on it. So moving on, we as you can see, we have a picture over here wherein it shows the cross-region backup using a DR strategy and also a multi-availability zone architecture for the availability. So next we have the recovery time objectives, that is RTO, and recovery point objectives, that is RTO. So these two factors are very important when you consider disaster recovery strategies. So let's look at the RTO, that is recovery time objective first. So this basically refers to the maximum acceptable downtime of a system or application. So this defines the amount of time within which the system should be restored and made operational after a failure or a disaster if it occurs. RTO is typically measured from the moment the failover occurs until the system is fully functional again. So this will be decided by the business owner. So he will give you a time till which he or his business can suffer This time basically defines the time wherein the infra should come back to its original state again and restore all the failures that it has occurred. So the factors that basically influence RTO includes the complexity of the system. So more the complex systems may require more additional time for recovery. So obviously, if you have a lot of complexity in your system, you will require a bit more time to recover. We have disaster recovery strategy. The chosen recovery method, such as failover, backups, or rebuilds, can impact the needed to restore the services. So this also depends on the recovery strategy that you use for your disaster recovery. The RTO will also depend upon that. Also, we have resources and infrastructure. The availability of your resources, including the hardware, software, and the personnel, can affect the speed of recovery. So the availability of all these things should also be there to achieve a good RTO. Next point, we have the recovery point objective, that is RPO. So this basically represents the maximum acceptable amount of data loss that is measured in the time. So this defines the point in time to which data must be recovered after a disruption or disaster. So RPO quantifies the amount of data that an organization is willing to lose in the event of a failure. So this will also be defined by the business personnel of whose the infra is of, and this will be defined by them, like how much data loss that can they suffer. And the factors that we have influencing the RPO is the frequency of data backups. So the more frequently data is backed up, as I suggested, you should have frequent backups of your data if it is very crucial and very important. So basically, the important data should be backed up very frequently so that you do not face challenges in future. So frequency of data backups is a very crucial factor influencing RPO, wherein more frequently if the data is backed up, the lower the potential of data loss is what you will suffer. So next we have data replication strategy. As I said before, if the data is replicated in real time or near real time to a secondary location, the potential of data loss is also minimized. So like it also depends on the disaster strategy that you implement. The rate of data generation and change. So the systems with high data generation or frequent data updates may have a shorter RPO. So next we have So next we will be seeing the various disaster recovery strategies that AWS Cloud offers us. So AWS offers a variety of disaster recovery strategies. Mainly there are 4 which they offer. So they are named as backup and restore, pilot light, warm standby, and multi-site. So in backup and restore, as you can see, AWS backup is a service that we can use. So herein, AWS backup provides a centralized and automated backup solution for AWS resources. It supports various AWS services like Amazon EBS volumes, Amazon RDS databases, Amazon DynamoDB tables, and more. So AWS backup simplifies the backup process, retention management, and the restoration of the data. So basically, this service helps you to centralize your whole backup process, and it will provide you a centralized way to find your backup, all of the backup of all these services at one place. Next, it also supports Amazon S3. So also Amazon S3 versioning. If you enable the versioning on Amazon S3 buckets to maintain multiple versions of app objects, this allows you to easily restore the previous versions of files in case of accidental deletions or modifications happened in your buckets. So with this feature, you can get your older versions back if needed, if required, by implementing the Amazon S3 bucket versioning. Next, we have database backups. So you should take regular backups of your Amazon RDS databases using the automated database snapshots that AWS offers, or the native database backup tools. So you can store the backups securely in an Amazon S3 bucket, or you can also use the AWS backup service for a centralized management, as I suggested before. Next, we have the pilot light strategy. So in a pilot light DR strategy, you maintain a minimal, you can say a minimal version of your production environment in AWS. This includes the core infrastructure components like the databases, application servers, and storage in your infra. So during a disaster, you can scale up and launch additional instances, restore data from backups, and redirect the traffic to the AWS environment that is hosted in another region by Pilot Light in the Pilot Light DR strategy. So here in AWS CloudFormation, you can use the AWS CloudFormation templates to automate the deployment of your Pilot Light environment. This ensures consistency, and it will speed during the disaster recovery process. And you can also replicate your on-premises databases to Amazon RDS or Amazon RDS multi-AZ deployment by automatic replication and failover capabilities. Next, we have the warm standby DR strategy. In warm standby strategy, you maintain a partially scaled AWS environment with essential resources running, but at a reduced capacity compared to the production environment. So this basically allows you to recover very fast during a disaster when it occurs, because you already have infra which is running in another region, but as it is using low capacity compared to the production environment that you already have in your primary availability zone. So it won't cost you much also, but you will get a very low RTO as I defined before. So here auto scaling, you can use auto scaling to automatically increase the capacity of your AWS environment based on the predefined policies or triggers. So this will help you ensure the resources are readily available for failover and recovery. So also continuous data replication is important. You should utilize the AWS data migration service or the storage replication services to replicate data in real time or near real time between your on-premises infra and the AWS infra. So next we have the multi-site or active multi-site DR strategy. So in the multi-site strategy, you deploy your infrastructure and applications across multiple AWS regions. So this approach provides you high availability and redundancy and minimizes the impact of a single region failure. So here AWS Global Accelerator can be used to route traffic efficiently across regions, where ensuring the optimal performance and the failover capabilities. Also, cross-region data replication, you can leverage services like Amazon S3 cross-region replication, AWS database service native replication features, or any third-party data replication tools to replicate critical data across regions. So it is actually very important to access your specific business needs, the recovery time objectives and recovery point objectives, and the budgetary constraints when choosing an appropriate AWS DR strategy for your infrastructure. So the combination of different strategies and services can be customized to meet your organization's unique requirements and for the DR planning and implementation. So here we come to the last topic, that is a case study. So herein we had a case study where there is a hospital called Calvert Health. It needed an infra to improve the electronic health records and system resilience and shorten the recovery time using the AWS Elastic Disaster Recovery. So basically the challenges that they were facing was that they required highly resilient architecture, and their major concerns were the RTO and RPO. As in, you can see it's a hospital, so they will require the data to be recovered in a very short time, and also they cannot suffer any data loss or a very minimal amount of data loss, because the data that they have is a very sensitive and crucial data. Also, they were at a location wherein they were very vulnerable to the disasters. So the location where the hospital was situated, and so like they were very prone to disasters also. So these were the major challenges that they were facing. So when they reached out to AWS, so AWS basically tried accomplishing the goal by giving them a solution wherein they deployed several solutions, like they included the Elastic Disaster Recovery, wherein in the backend, this service actually uses the disaster recovery strategies that I previously explained to you all. And this helps them minimize the downtime and also the data loss with fast and reliable recovery of on-premises and the cloud-based applications. So using this actually provides affordable storage, minimal compute, and point-in-time recovery. So this service also reduces the cost by giving them a resilient infra in return. So it is also they also used the AWS backup service, which organizers can use to centralize and automate the data protection across AWS services and hybrid workloads. So as I uh, explained before, AWS backup is a very good option when you want a centralized backup for your whole data. So you can centrally manage your whole backup, may it be a very huge backup of TB or petabyte config. So Calvert Health network engineer basically worked alongside with the healthcare triangle and the AWS team to deploy the AWS disaster recovery and AWS backup service on almost 140 servers that they hold. They pulled the information through a VPN setup that helped them to replicate the data in the AWS environment. The changes reduced the Calvert Health's RTO from 72 hours to under 2 hours. That is almost 97% of the improvement. So this helped them achieve the also this helped them achieve a resilient architecture, obviously, but also the major concerns that they faced, that was the RTO and the RPO, were also reduced up till 97%. And this improved the overall problems that they were facing before through AWS services that they got provided by. So yes, there we come to an end to our webinar. If you have any questions, we are open to answer. Suvarna ma'am.
Yes, Rutuja. Thanks, Rutuja. It was really an informative session, and I hope all our attendees have found it useful. And thank you all for attending the session. We are open for question and answer. If you have any questions, you can type in the questions box, or you can raise your hand. Rutuja, so far there are no questions, so I guess we can conclude the session. Thank you all. Thanks for attending the session. Thank you.
Thank you.